In this video, I want to talk about a common mistake often made when working with rational expressions. Say you have a rational expression like this, 4 plus 3x over 2. Well, sometimes someone might say, oh, well, I've got a 2 here in the denominator and 4 here in the numerator. 2 goes into 4 evenly, so I can just cancel. Well, 2 goes into 2 once and 2 goes into 4 twice. That means that you're left with 2 plus 3x over 1, which is just 2 plus 3x. But that is not correct. You can't do that. To just make that even clearer, let's take a look at what happens if we were to sub a value in. If we let x be equal to 5, well, in our original statement, 4 plus 3x over 2, we get 4 plus 3 times 5 over 2, which would be 4 plus 15 over 2, which is 19 over 2. In the simplified version we tried to get to, by making an error, we got 2 plus 3x. That would be 2 plus 3 times 5, which would be 2 plus 15, which is 17. And those are not equal. So clearly 4 plus 3x over 2 can't be equal to 2 plus 3x. So you can't do that kind of canceling. Let's take a look at a similar example. Here we've changed the number slightly. Now what you could do in this case, and it would be completely correct, is you could look at the numerator and say, well, I've got a common factor in the numerator of 2. So I can pull that 2 out front, which leaves me with 2 plus x in brackets over 2. Now I have a common factor of 2 in both the numerator and the denominator, and both the numerator and the denominator are fully factored. In other words, everything's multiplied together. There are no pluses or minuses exposed outside of brackets here, just kind of dangling off outside the brackets with numbers. The only plus that we see, or minus for that case, is inside of brackets. So this is fully factored. In this case, now we can cancel the 2 and the 2, and we're left with 2 plus x. And that is correct. These two are equal. To illustrate that, again, let's let x be equal to 5. In the original expression that we get 4 plus 2 times 5 over 2, which would be 4 plus 10 over 2 is 14 over 2, which is equal to 7. And in our simplified version, we got 2 plus x, which would become 2 plus 5, which is also 7. Now, these are equal. So now we see that 4 plus 2x over 2 is equal to 2 plus x. And the reason that's the case is because of this step in between. We could common factor a 2 out of 4 plus 2x, get 2 plus x, and then cancel. But we could only do that because this was the fully factored form. So note, you can only cancel out from fully factored expressions. You have to do all the factoring first, make sure there are no exposed pluses or minuses anywhere before you can do the canceling. Again, let's take a look back at the different cases. Here, there is an exposed plus. This plus is outside of a bracket, so we couldn't cancel. Whereas later, we saw in this case, this was the only plus, and it was not exposed, it was within brackets. This was fully factored, so then we could cancel. So again, you can only cancel out from fully factored expressions where there's no exposed plus or minus signs outside of brackets. Important thing to keep in mind when working with rational expressions.